The history of software engineering is a relentless march away from the machine. Every major leap forward pushes humans away from mechanical execution. We stopped manually allocating registers in assembly and let compilers do the heavy lifting. We moved to higher-level languages, writing C++ or Python syntax, trusting the layers beneath us to translate our logic into zeros and ones. Now, the industry is finalizing the most extreme abstraction layer yet, Agentic Engineering. We are extracting the human from the entire middle of the delivery pipeline. The manual breakdown of tasks, the translation of logic into low-level component design, and the actual typing of syntax are being handed over to autonomous systems. A single, well-engineered prompt from a human now acts as a strategic trigger. It launches a massive swarm of autonomous agents that decompose the request, write the code, generate the tests, and iterate on their own errors in seconds. This breaks the traditional definition of a developer. When you no longer spend your day writing syntax, the skills that made you valuable yesterday are no longer the skills that will keep you employed tomorrow. Organizations are rushing to deploy these hyper-fast, round-the-clock AI agents, yet they are finding themselves paralyzed by low throughput, massive backlogs, and severe developer burnout. The problem is structural. Engineering teams are attempting to force machines that process at the speed of compute into legacy Agile workflows built for humans who sleep. Applying 2-week sprints, manual sprint planning, and poker point estimations to continuous agent swarms artificially throttles their capacity. To survive this transition, engineering leadership has to tear down the traditional software development lifecycle. You cannot bolt autonomous capabilities onto legacy processes and expect to win. The organization must be redesigned from the ground up. That redesign begins at the most granular level possible, redefining the daily job description of the individual engineer. Traditional Agile assumes software development is a deterministic process. LLMs and agentic systems are inherently probabilistic. They require constant verification, not just rigid planning. Treating AI as a faster typewriter within an old process is exactly the kind of corporate failure that guarantees obsolescence. We have to start treating the modern development platform as a probabilistic compiler. Just as a traditional compiler accepts source code and outputs a binary, this new compiler accepts human intent as input and outputs verified, production-ready software. Because the middle of the pipeline is autonomous, the human effort migrates entirely to the edges. Your job is now defining exactly what should be built and verifying that the machine built it correctly. This creates a new role, the architect of intent. This is an engineer who combines the strategic thinking of a product manager with the precision of a systems architect, focusing entirely on managing context and constraints rather than typing syntax. This diagram shows boundaries an architect must define to guide the platform. Left, quality gates for strict evaluation, and behavioral contracts specifying precise edge cases. Right, resource boundaries enforcing token budgets, and governance policies establishing the security and ethical rules constraining the agent's autonomy. The compiled code is no longer your primary intellectual property. The true value of your engineering team now lives in these engineered contexts, system prompts, and evaluation suites. Even with perfect constraints, a human still has to review the output. And that leads to a crisis known as the morning avalanche. Engineers arrive at 9 a.m. to find dozens of pull requests generated by agents working through the night. The volume vastly exceeds what a human can consume. To fix this, the traditional, synchronous pull request has to be abandoned entirely. It is replaced by the Plan, Execute, Verify, or PEV loop. Here, multi-agent quality gates plan the change, write the code, and run the tests. If it fails, the agent self-heals and retries without human intervention. This continuous execution creates a new operational reality, the 24-hour delivery cycle. The outer gold ring shows agents executing around the clock, proposing code and running tests. Human effort, marked in blue, is concentrated purely into focused review windows during core business hours. Because the work never pauses, the morning stand-up becomes obsolete. Teams replace it with the agent run. Instead of humans reporting what they did yesterday, a meta-agent generates a digest of what the autonomous fleet produced overnight, filtering the noise so humans can focus on strategic exceptions. Software production has officially outpaced our ability to absorb it. The bottleneck has migrated from the generation of syntax to the strategic validation of machine-scale output. This volume of machine execution creates severe financial opacity. Enterprise teams are running an invisible workforce. The tokens consumed by agents doing this work represent real expenditure, often exceeding the cost of junior developer salaries, yet they sit hidden inside miscellaneous cloud infrastructure budgets. Human Resources owns the headcount ledger, tracking salaries, but no single department tracks the variable cost of inference. An engineering leader might have 40 humans on their payroll, but they are managing the capacity of a team more than twice that size thanks to machine coworkers. Therefore, the nature of hiring has to change. When an engineering manager needs more capacity, the decision is no longer which human to hire. They must decide if the next unit of capacity should be a human, a machine, or a hybrid bundle of both. The organizational chart must expand to map a new reality. Production now centers on the human plus agent pair, where a single engineer acts as a manager for a swarm of specialized orchestrated subagents. Treating these agents as a formal hybrid bench means holding them to professional standards. They require structured escalation paths, dedicated performance management for model drift, and clear incident attribution for errors. Planning now revolves around investment rather than hours. Leaders must allocate token budgets against strategic outcomes, treating inference costs as the primary variable in the production function. The delivery pipeline is now a continuous loop. It is probabilistic in its execution and entirely autonomous in the middle. The engineer remains the critical center of this equation, acting as the ultimate risk owner. This role demands a mastery of context and intent architecture, providing the strategic oversight that probabilistic machines cannot provide themselves. Their role requires a broader understanding of the entire system, using subtle, highly deliberate constraints to guide a massive, dynamic force. The organizations that survive this transition will be the ones that recognize this reality. You have to stop managing artificial intelligence as a faster tool for typing code and start managing your engineering team as a continuous orchestra.